is no surface fully smooth. Even polished glass has microscopic grooves. And when two objects come to touch, the frictional force resists the motion's push.
And this force is acting opposite the way that objects try to slide against the relative motion on the side. We know it's not conservative force doing work, and that two-thirds are static friction, holding objects to kinetic friction against the motion's push. And we all know the stronger one is the static type.
And the force is called friction. Normal times the constant of the type. Always vice things trying to slide. Separate surfaces sliding by. Let us find the normal, and multiply by the mu. Kinetic fricks, what that leads to. The static friction's less than 2. My friends and I, we've got the hacks. Static friction rises with the force till it's max. And everyone who knows this knows that mu drops down low. Kinetic fric and motion go. And this friction is dependent on the normal force that objects feel, like the surface pushing up on objects tastes us weird, but we don't care. The larger normal means more friction.
Then the mu is saying just how grippy that two surfaces are, dependent on texture, materials, shape, but we all know the larger mu is the static one.
And the force is called friction. Normal times the constant of the type. It always fights things trying to slide. The separate surfaces slipping by. Then we find the normal and multiply by the mu. Kinetic fric's what leads to. The static friction's less than 2. How? It's cooler than we ever dreamed. We're smarter than we really seem. How? All the static friction's variable, but kinetic fric won't change with speed.
And force is called friction. And what times the constant of the type. But always finds things trying to slide. The separate surfaces sliding by. Let me find the normal. So multiply by the mu. Kinetics, what that leads to. The static friction's less than 2.